and in townhomes. So you get the idea. So what our next step is, now that we have access to all this data, we need to match that with our internal customer records. And the way we do it is using something called fuzzy matching. It's basically a mathematical approach that doesn't just say 0 or 1, like it's a match or not. It kind of blends it and see the what's the percentage likeliness. So we have customers entering. Our associates are picking up customer data from every store. So let's say I'm a customer. I go into a store in Sherman Oaks. The associate there might enter my name as my full name. Enter the state as CA. Somebody else. Sorry, I could go to another store, maybe in Hollywood, and then the associate might just have my first name. The last name is just a short form, or they could do an error in entering my name too. So what fuzzy matching does is it shows the likeness of all these records, and then we can use a logic to say, okay, all these customers are actually the same customer. We do that with Experian data too. So when we cross-verify, the way we have our customer records could be a little different from how Experian has it. So we use the fuzzy matching to get a good match between internal and external data. Now, initial read, how does a platinum customer compare to rest now that we have all the data? Just demographics, they lean higher in the 50 to 70 year age range. Household income is higher, 100K plus, index is higher, and even more in the $175,000 household income range. More men, more female, more male than female. And these are customers who typically have bought an upscale merchandise, somewhere else too. So initial read. Now that we have all these attributes, we need to look at the predictability of the data sets. You can use any methodology you're comfortable with. It could be a regression analysis, could be a decision tree. But the goal is to make sure all these attributes you're looking at are predictable. And we did find that when we look at mosaic segmentation, they seem to be the most predictable on the purchase behavior of platinum guitars. So to give an idea, this is how the top 15 mosaic segments look for the chain. Again, you can see all these funny names pop up. P08, babies and bliss, that's the top segment. Boomers and boomerangs, sports utility families. So how does this look for platinum? You can see some of it, a lot of it changed, or some of it changed. So aging of Aquarius, that's a top segment. Upscale boomers, aged couples, living in city and close-in suburbs. A03, kids and family, prosperous middle-aged married couples with children living child-focused lives in affluent neighborhoods. So another metric that, so what this says is these are the top platinum customers for Guitar Center. We also wanted to know who are those customers who are not just buying platinum gear, but when they do buy, they give a preference to platinum gear over any other gear. So that we developed an index to look at the proportion of what they buy within platinum compared to rest. And here you will see a totally different segments pop up. So the top segment here seems to be jet set urbanites, platinum prosperity, urban rich, urban edge. So now that we have all this data on, we know what factors are predictable. What we do is, as I mentioned earlier, we have the ability to look at all customers within our trade area, which is a 30-minute drive time. So once we know who our customers are, then it becomes just a modeling exercise to figure out what existing stores are the best markets to open these platinum stores. So, and that's what we did, and it was a really, when we did follow this methodology, the results came in much, the new stores that we picked up performed much better than what we had previously. So that's a success. But at the same time, one of the drawbacks of using a data-driven methodology is you always have to blend it with contextual knowledge too. One place that we completely missed out based on this purely data-driven approach is looking at border stores. So there are certain stores in border of Canada that does get a lot of upscale buyers, but since our data set was just confined to US, kind of missed on some of those. Okay, now going to move on to another kind of project. What we do, as I mentioned earlier, with all the data that we have a great ability to do a lot of testing related to any kind of initiatives that we roll out chain-wide. So before we do a complete chain-wide rollout, our intention is to test it as much as we can, make sure it is working the way it is before we roll it out to the chain. So just a simple, initiative that we can probably run through and probably give you an idea of how we do the testing. I think most of you might be familiar with how A/B testing works on the website. It's pretty easy to do it on the web because you can serve different results to your audience. It's very easy to get a lot of population that reads it, but with the stores, it's always a challenge. So hopefully, our approach might, we had to look at an approach that could help us do those kind of testing, similar to A/B testing. So to start with, let's look at a case study for guitars. Let's say we just, decide how we change how we display guitars at the stores. Instead of say putting it on a wall, we are now, I'm just throwing an example. It could be any other, case. Let's say now we're making it more hands-on for customers to play, and we want to know what the impact is. And for us internally, for it to make sense to do a chain-wide rollout, let's say we need at least a 2% sales lift to make it successful. So the way we do it is, we pilot it in a few test stores. We pick up stores based on, making sure that, the number of stores we test at gives us a good statistically significant results. So here's the first, graph that I want to run through. Let's say this is the launch of program, and we are seeing a 2.5% sales increase compared to last year post-launch. Does that make this initiative a success? Yeah. What other data do you need to, Yeah. So one is pre-post. Let's say the same test stores were performing at a 6% increase in the pre-period, and then you roll it out, then it drops to 2.5. So does that mean this is a failure?
Yes, sir.
Yeah. So let's say we have a set of stores that are we have picked up comparable stores. Pre-period, they're pretty good match. We roll it out, and then the blue line is the test stores. The red line is the control stores. Now is that a success?
Maybe.
Yeah, probably. Yeah, most likely it's a success, but yeah.
Attrition is a big problem. But
Yeah. So here, maybe, I don't know, this is probably just seasonality, that was probably, just to give an example, the pre-period was in December, November, and then the post-period is January. Just from a seasonality perspective, you'll see that drop in sales. Or it could be some other event that might have triggered that drop. So it's always important to, measure not just the pre-post, but also against test and control. So that's the methodology. You take test results from test stores, measure it against a well-matched control group. The keyword here is well-matched. And then have a t-test to see what the results that you're seeing is, whether it's statistically significant or not between the test and control stores. it's really important to get a good match on the control stores. And the way we try to, it depends on the metrics you pick. And ideally, the way it should work is when you have no event happening in the pre-period, then you should have zero impact. So if you run a null test, then you should have like zero impact when there's no event happening. So that's the ideal case scenario of getting a good control stores. But then it's almost impossible to get that. So there's always some error rate, and our goal is to minimize it. So based on our iteration on looking at what metrics probably give us good control stores, some metrics that we've seen that helps us is seasonality. We need to factor in seasonality, we need to factor in growth, and we need to factor in sales volume, like what's the overall sales volume that store does. So different stores react to seasonality differently. There might be a store that is more seasonally reacts seasonally to say back to school time frame more than maybe the holiday season, or vice versa. So growth, it's important to make sure that the test stores that you pick have similar growth trajectories compared to the control stores, and finally sales volume. So, and then we use a k-means nearest neighbor algorithm to pick like stores once we have the metrics in place. It's just a really fancy word to say it's basically a Euclidean distance between 2 points on a multi-dimensional space. So if you're I don't know if you're all aware of what k-means nearest neighbor algorithm is, but let's say you take a classroom, you have a class of students, and you want to, they're all, one of the metric that we're looking at is their height, and we want to know if you pick a random student, and let's say his height is 5 feet 8 inches, and you want to know who's the other student in the class who's closest to him in height, then all you can do is you can just take the difference in heights for all the students, and the one that has the lowest difference is the closest neighbor. You can do that similarly in multi-dimensional space, and that's how we get to our control stores. So that's all I had. How do we do it on time?
7 minutes.
Okay. Any questions?
K-means usually involves, you've got to tell the number of clusters. That's what the K stands for.
Yeah. Euclidean, right? Yeah. Yeah.
Okay.
Yep.
Can you repeat the question?
We probably already discussed this in the beginning of your presentation. I understand you said 40% of the customer usually you try to capture people within 30 minutes driving distance. How did you define the 30 minutes as the buffer zone?
So we take all of our existing. Oh yeah. So I'm going to repeat her question. So her question is, how did we come up with the conclusion that our trade area is 30 minutes around the store, say instead of 5 minutes or 40 minutes? So we looked at historic customer records. We plotted them on. We had their addresses. So we converted that into latitude and longitude, plotted them around the store, and we looked at what drive time radius gives us, like captures 80% of these customers. And for us, it came up to about 30 minutes. So that's how we use a tool called Outrix that does that. So you can use open source tools too.
So what did you find in the end? What were the factors that determined whether or not the platinum route was going to be successful?
Yeah, so looking at mosaic segmentation was key. That was one of our really key metric that we decided. Looking at household income also popped up as one of the key metrics as well. So basically, we use that data to come up with a list of of the 285 stores, where else we could be opening platinum stores, and we open these rooms, and the key metric is what kind of lift we saw, again, using test and control, when we open these platinum stores compared to, what kind of lift we see in sales. So that's how we, measured it.
With the fuzzy matching and the mosaic segments, how did you guys handle mosaic overlaps or segment overlaps between the different mosaics? Or was there kind of you just pick the kind of a hard boundary between the logic? So either how to pick the hard boundary or how to handle overlap?
So your question is how do you...
the mosaics, the mosaic segments, right?
Yeah.
There can be elements of overlap or there can be hard boundaries with fuzzy matching. So I wanted to know, how did you approach the problem of potential overlapping with mosaic segmentation?
So each address has a very specific mosaic segmentation. So we use fuzzy matching to see if our records that we have for customers internally, to get a match to the Experian record. And they have the address in their records too. So once you get a match, it's clear what mosaic segmentation it belongs to. But getting that match sometimes can be really tricky. In fact, the toughest part of the whole project was to increase that rate of match. So it's a very data-intensive process. It takes. It's really challenging to get that clean match between internal records and external.
I'm actually using Alteryx for fuzzy matching right now also.
Oh.
And so my question to you is, how do you, so when you set the threshold, right? You set it at 100%, 99, 95, whatever. Let's say you set it at 95%. You still, when you look at the output of that, you still see so many that are mismatched.
Yeah.
So how do you sort through that? Is there a manual thing?
Yeah, so you need to be, so this question is, how do you make sure, is use Alteryx, even if the match rate is 95, he sees a lot of mismatched records, so how do you make sure you're able to get a good match? And that's a good question. In fact, the process of getting the rules that we set to match, it's kind of an evolution. Like, first you look at, okay, if there's a match on, it could be different rules. So if the street name matches, the first name matches, and the state matches, then that's a match. So you can do it in a step-by-step process, to get a cleaner match. You have to be really clear. You need to revisit those rules to make sure it's a step-by-step match process. Like, get one stage where it's like you're 100% sure that these are matches. What rules will get you that? Probably the match rate will be really low. And then step 2, take another set of rules and kind of get to that answer.
So does Experian actually give you a list or data set of all 220 million people and their names, addresses, segments?
Yeah, they do. It's scary, right?
If they do, what is that your privacy?
That's a good question. It's kind of scary that your data is out there for anyone who can purchase to run analysis on. But yeah, they do provide name, address, and all these 300 plus attributes. And there are other providers of this data as well, not just Experian. So there's, I think there's a provider called Axiom, that gives like 1,000 plus attributes, per individual. So yeah, that's a good question. I don't know. It is a concerning, aspect. Okay, last question.
So I was kind of wondering, after installing more platinum stores, the customers that are interested in buying these very special instruments, I would expect that they would be willing, for instance, to drive a longer distance to a store, since
Yeah.
This is usually not available.
Yeah.
So do you actually see feedback from installing the stores that then your trade area also becomes bigger, for instance, so you have to readjust the parameters?
No, that's a good point. We look at things in aggregate, but maybe we should revisit and look at specific stores and see how they behave. Yeah, we do see a lot of variance. It's not that for every store it is 30 minutes.
And
It's just a rule of thumb for us to build an analysis. So there are stores where it is 45 minutes. There are stores where it's almost an hour plus, and And like places like here in LA County, we have a really high density of stores, and it's actually lesser. But for most of our analysis, we just take an average, just like a rule of thumb to build our analysis. Okay, so thank you very much. I hope you all